Hi everyone, welcome back to the course on solid state. So in the previous video, we discussed about what are the general characteristics of solids and why there is a necessary of studying this chapter solid state. Now in today's video, we are going to discuss about the classification of solids. So how the solids are classified. As you know, the solids, the particles in the solids are closely arranged, and the arrangement of particles is different from one solid to another solids based upon the nature of order of arrangement of particles in the solid substance. The solids can be classified into two types. And those types are crystalline solids and the second one is amorphous solids. So these are the two types of solids which are classified on the nature of order of arrangement of particles. Okay. Order of arrangement. Now, what are crystalline solids and what are amorphous solids, and how the particles are arranged in crystalline solids and amorphous solids, that we are going to study. The first type of solid, that is crystalline solids. So now we will see what are the characteristics of crystalline solids and how the particles are arranged in crystalline solids. In crystalline solids, the order of arrangement of particles is regular. Okay, you can observe the regular arrangement of particles in case of crystalline solids. So, due to this regular arrangement of particles, the crystalline solids have definite geometry. Because of regular arrangement of particles. Okay. So, here due to that regular arrangement means the particles are throughout the crystal, the particles are arranged in regular manner like this, so that the ordered arrangement will be observed in case of crystalline solids, and hence the shape of crystalline solids is definite, means they have definite geometry. Okay, and the another characteristic of crystalline solids is these crystalline solids are said to be true solids, means they show the properties of a solids, the characteristics of a solids, and hence they are considered as true solids. Okay, and in crystalline solids they are exhibit long range order. So what does this long range order means? Long range order means if you observe the arrangement of particles in crystalline solids, as you know, the particles are closely arranged in solids, but in case of crystalline solids, these arrangement of particles is repeated over a regular interval of time, means the particles arrangement repeats periodically after certain time. That means if you consider this one as the first line, this second line will also arrange in the similar manner. After the particular number of particles, the same pattern is repeated, and thus we say that there will be regular arrangement of particles which repeats periodically over the regular interval of time, and this type of arrangement is repeated throughout the crystal. Okay, so this type of arrangement you can observe throughout the crystal, and hence it is said to be long range order. Long range order means the particles are arranged in such a manner that the pattern will repeat periodically for long distances, and hence it is said to exhibit long range order. Okay, so this is one of the characteristic of crystalline solids. Then the fourth type or fourth characteristic of crystalline solids is they have sharp melting point and boiling point. They have sharp melting point and boiling point. What does this sharp melting point and boiling point means? If I say what is the melting point of water, we will say it is 0 degree Celsius, or melting point of ice is 0 degree Celsius. And if we say some other crystals like iron or the copper, if you consider such kind of solids, they are all having a particular definite melting point. So you can mention that exact melting point of the solid. So if I say the melting point of iron is 1373 Kelvin. Okay, this means it sharply, when it reaches this temperature, that iron will starts to melt. Okay, and such type of solids are said to exhibit a sharp melting point. Okay, so this is the another characteristic of crystalline solids, that is they have sharp melting point as well as a boiling point. Next, the crystalline solids are said to be anisotropic in nature. Crystalline solids are said to be anisotropic in nature. So what does this anisotropic nature means? Consider this one as a crystalline solid, and in this crystalline solid the particles are arranged in regular manner, and one of the particle is having larger size and another particle is having a smaller size. So now in this crystal I will pass a ray of light from one direction. Suppose, consider I will pass the ray of light in this direction. Okay, now when I pass the ray of light in this direction, the speed or velocity of light will changes, because as you know, when a light travels from one medium to another medium, its velocity slightly changes. Okay, now when I move or pass a ray of light through this direction, it gives a certain value. Okay, and I will mention, I will note down that reading. Now I will pass the ray of light in this direction. Okay, now the speed of light, when I pass in this direction, the ray of light, it is having a speed around about, consider 2.98 into 10 raised to 8 meter per second. Okay, now when I pass the ray of light in this direction, will it gives the same value or it changes? You can observe here, when I pass the ray of light in this direction, it moves through the particles which are having a smaller size. And when I consider this ray, it moves through the particles where the alternate bigger and smaller particles are present. In such conditions, the ray of light, its velocity has different values. For this, if it is 2.98 into 10 raised to 8 meter per second, then the velocity of this ray of light, it may be 2.97 into 10 raised to 8 meter per second. So it is due to the change in the number of particles and size of the particles through which it passes. Here all the particles are having smaller size, but here the particles size is different, and hence when we measure the physical properties values from different directions of the same crystal, they have different values for crystalline solids. It is because of arrangement of particles. Okay, due to the change in the nature of particles through which we are passing the ray of light, okay, there it gives the different values, and hence this type of nature where the physical properties values are different in different directions are said to be anisotropic in nature. This property is said to be anisotropy. Anisotropy means the physical properties values are different in different direction when measured along different directions in the same crystal. Okay, this is the nature of a crystalline solid, that is anisotropic. That can be explained with the help of this example. Or you can measure not only the velocity of light, you can take the refractive index, okay, electrical conductivity, thermal conductivity. All such physical properties have exhibit different values in different directions. Hence they are considered to be anisotropic in nature. So this is the another characteristic of crystalline solids. The next one is the crystalline solids. These upon cleavage, they will give definite planes having definite planes. Okay, the pieces with definite planes will be observed upon cleavage. Cleavage means cutting. So when we cut the crystalline solid, it will give the pieces with the definite planes. Suppose if I consider this one as a crystalline solid, and if I cut this, it will give the two pieces having definite planes. Okay, irregular surfaces will not be obtained. Those pieces which are obtained upon cutting the crystalline solid will have the definite shape with smooth surface or regular surface. Okay, so this is the cleavage property of the crystalline solids. Okay, so these are certain characteristics of crystalline solids.